Oh my God.
It was an accident. I was putting something
You done had like 11 accidents.
It fell off the desk. I was very clumsy. Y'all just saw me drop my finger spinner like 2 times, and then my water bottle. Come on. I need that glasses to drop it. That only means I can see good. You can see it.
Blessed assurance. All right, thank you guys. Thank you. Thank you. Thank you. All right, has everyone written this function on their notes? They should have. All right. Now let me remind you guys about something, right? Here's a graph. Change my color. X and Y axis, quietly, please. You can if you please. X and Y axis. If I just were to throw some arbitrary function up here, right? Whatever. That's a function. Wherever the function crosses the y-axis is naturally going to be the y-intercept, right? Super ugly, it doesn't matter, right? Now listen, hold on. There's something about the value of x all along the y-axis. The value of x is always what? All along the y-axis. It's always 0, okay? So technically, young people, if I wanted to determine what the y-intercept of a function was given a function, not a picture. Remember, I don't have a picture. This picture doesn't exist. I don't know what this function looks like, okay? I don't know what this function looks like. But if I wanted to figure out the y-intercept algebraically, I would simply plug in 0 for x. Because all along the y-axis, okay, the value of x is always 0. If you want to figure out where a function crosses the y-axis, plug in 0 for x. All right? So here we go. Hold on. Hold that thought. Now, we've plugged in 0 for x. Take the earbuds out. 0 raised to anything, any power is just going to be what? Don't believe me? You can use your calculator if you please. And then 3 times, or any number times 0 is just going to be what? It's just going to be 0, right? Same thing. 0 squared is 0, Christian. 0 squared means be quiet while I'm teaching. Use the paper. All right. 0 squared is 0, right? And 0 times any number is just going to be what? Minus 1. And naturally, 0 plus 0 minus 1. Why did I put a 7? I've been doing that all day. I don't know why. That's crazy. I need to play the lottery. All right. 0 plus 0 minus 1 would naturally give me -1, correct? Right? Now, look back at that equation, young people. The only term that does not have a variable is -1. Looky there. Young people, the constant term of a function, of a polynomial, okay? The constant term of the polynomial will be where it crosses the y-axis. Plain and simple. So let me be clear. If they're asking you for the y-intercept, the y-intercept is an actual location. You wouldn't just put -1, okay? You would put the actual point itself, okay? So what would be the point? 0, comma what? Very good. And then we've been asked to find the number of zeros. Now, Najee, we already talked about that topic last week, didn't we? How do you know how many zeros a function has or a polynomial has? Anybody remember? Yes, Skylar. Very good. The highest degree. Okay. What is the highest degree of the given function? So how many roots does this function have? 4. Period. Okay. Y-intercept is 0, -1. And this function has 4 zeros. Yes. No, baby. Hold on. No. We just found the y-intercept.
No, I'm saying, like, That 4 is 0? Like the
It
height-
tells you how many zeros it has. Because it's the highest degree.
is 0.
No, listen. The degree tells you how many zeros there are.
That's what I'm saying.
Yes.
I know this.
All right. Give me a question, Christian.
How you plug in 0?
Why did I plug in 0 for x? Come on.
You said that x will always be 0 on the y-intercept.
On the y-axis, all along the y-axis, no matter where you go. Okay? Come on, say it. And we're looking for the y-intercept. So for any function, if you want to find the y-intercept, just plug in 0 for x. Okay? But I also pointed out that the constant term of the function will be the intercept. Okay? So quickly, with that being said, what is my y-intercept? Najee? What's my, anybody can answer. I just calling his name because his head is down.
15.
It's 15. So how would I name that as an actual point?
0, 15.
0, 15. Now, if you want to, you can plug in 0 for x, Ramaya. You can. But for what? If you know, because remember, if I plug in 0 for x, that's going to be 0, right? If I plug in for 0 for x, that's going to be 0. Leaving just what?
15. And I know the number of zeros.
How many zeros are there?
I can merge. It's 2.
It's 2. Why?
Because that's not shush, man.
You're not gonna be a little angry Smurf about this.
Because she trying to steal.
You can't be grumpy Smurf over here.
Steal my shit.
Calm it on down, okay?
It's 2.
You better hop out the window because she said the answer instead of you. It's 2. Why? You aggressive with the answer? Moving on, y'all. I can't. All right. So with that being said, time for you all to show me what you're working with, okay? So I'm gonna pass out, and I only want you to do 1 through 6, okay? You guys are gonna have 10 minutes to do this. Of course.
This is rare.
I know. Bask in the glow of this worksheet, right?
Oh, this is rare. Instead of a
Maybe I
delta,
should play the lottery today. Or y'all should play the lottery today.
yeah, I always do. Like I literally always do.
I haven't eaten today.
You get any coffee?
Did you eat your popcorn?
I did eat some popcorn. I did eat some popcorn.
Well, that popcorn ain't good.
You got some
Who eats
coffee
that
today?
anyway?
When I go to the
Yeah.
Y'all are clowning me. You know what? I didn't have coffee out of my machine. That's my problem. That's the difference. That's the difference. Only 1 through 6, y'all.
You don't need too many more days like this. I'm gonna need you to drink that coffee every day. This here can't happen. No more.
What?
Only 1 through 6, you guys. Only 1 through 6. Did everybody get one here? Did I get one? All right, party people, let's get to work.
Yeah, I love writing on paper, man.
Okay.
Like
Is it the texture or something?
on a notebook, like it just feels soft writing with pen, so it just feels. The pencil, I don't even write with pencil. That's bad.
Hey guys, feel free to work together. You do not have to work in isolation.
Come on, Miss B.
No, I am not going to be your partner.
That's crazy.
Uh-huh.
So I'm guessing y'all did the graphs yesterday?
All right, guys, let's look back at our worksheets. Let's go.
Can I finish these?
No, baby, I'm about to go over these. Just roll it on up. Because I don't want you to miss this, okay? Baby. No, I don't want you to miss anything. We'll prove it. Take it to Mr. Brad and let him check it. Baby, sit down. Thank you, sugar baby. All right, here's the first one. You can see that, yeah? All right, what is the domain of this function? Thank you. Negative infinity to positive infinity. Yes. Yes. Because what you gave from negative, what you're telling me is that only the values from negative infinity to 3 are a part of this function. Yeah, it keeps going. So why would you stop at 3? You feel me? All right. Now the range, remember when you're developing the range, the interval for the range, it's the bottommost value all the way up to the topmost value, right? So remember, this doesn't stop, even though it's truncated by the, by the graph. Keeps pointing down, 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 down forever. Now, what is the lowest most point of this graph? What's the smallest value? What's the smallest y value of this graph? Negative 10 is the smallest. Remember, these arrows mean what? Does this graph stop at negative 10? What is it, baby? Thank you, Dejan. Smallest value is negative infinity. It keeps going. Yes, the graph, they can't graph the whole thing, y'all. How they gonna put forever on a piece of paper? Right? And then the highest point, okay? What is the highest point of this graph? To 9. Boom. And a bracket on 9, because that is the highest value of my graph. Does that make sense? Okay. Now, y'all swore up and down that I didn't teach y'all about zeros yesterday. I know I did.
No, we did.
Oh, but we did. The zeros very simply are located where? On the x-axis. Okay, so where does the graph cross the x-axis? Negative 3 and 3. No, because it's not an interval. It's not a point. It's just a list of numbers where the graph crosses the x-axis. All right. And then finally, what is the location of the y-intercept? You just put a 9? Thank you. You must put a coordinate, 0, 9. Very good. You must put the coordinate. The intercept is a location. Okay. Questions or concerns? Yes.
Did we talk about parentheses?
Yes.
Mm-hmm. Even though you guys are taking notes, you don't have the parentheses, you take points taken off.
Points taken off, I'm gonna mark it wrong.
That's not good.
Cool.
Next thing.
Cool. It ain't the answer. So why the devil won't you just write the doggone parentheses down or the brackets down? Then I'm gonna forget to give you your points. Okay, okay. Number 2.
One more. Talk about smallest to largest.
Mm-hmm. Mm-hmm. All right. Here comes number 2, folks. All right. What is the domain of this function? Thank you, sugar baby. Negative infinity to positive infinity. If you don't have your parentheses, it will be marked wrong. We are naming intervals, okay? What is the range of this function? Remember the 3 scenarios that I showed you guys? When the range is negative infinity to positive infinity, lower bound to the highest most point, Lower, upward bound to the lowest most point. I didn't show you guys examples of this. I know I did. And y'all looking at me like, what? Because you was on your phone. What's the lowest most point of this function, y'all? Thank you, baby. And what's the highest most function? I'm sorry, highest most value? Positive infinity. This is an example of from negative infinity to positive infinity of your range, where your range has the interval of negative infinity to positive infinity. Okay? What are the zeros of this function? -3, 0, and 2. Okay? And then finally, what is the location of the y-intercept?
0, 0.
Very good. Okay? Any questions or concerns about this one? All right. Here comes number 3. Bless you. Quickly, what is the domain? From negative infinity to positive infinity. What is my range? What is the lowest most point on this graph? Yeah, -20. And make sure you place a bracket around -20. Because -20 is a part of the range, yes? And this function goes from -20 all the way up to what? Positive infinity. Okay? Remember, this goes up and up and up and up and up. Yeah, I've seen some real ugly infinity symbols, and it's cool. Don't try to, the more you do it, the better you get it. And I've been doing it for almost 20, well, I take that back. I've been drawing the infinity symbol for about, actually 60, thank you.
You over
You're
60?
lying.
There's no way you over 60.
For 67 years, I'll have you know.
Yeah.
You over 67. I'm 30.
So my zeros are, okay, what are my zeros? All right. And where's my y-intercept located? All right. Where does it cross the y-axis? Wait. The zeros. Where it crosses the x-axis?
Oh, yeah.
All right, y'all. Number 4. Actually, I'm going to just cut all of this and see what we can see. Try to save time. All right. Let's focus on number 4. All right. So what is the domain? Quickly. Yep.
Is that always that?
Yes. For every polynomial. Yes. I say yes. I don't know why. You wrote it in. Well, you don't take good notes.
No, I took some good notes.
So did you write for polynomials? The domain is always all real numbers?
But he said this ain't
Okay.
no polynomial.
Who said that?
He said number 1 are only polynomial.
That's what he said.
Yeah.
Who said that?
Chris.
Who?
Chris.
Who is Chris?
Chris.
I don't see a Chris.
Chris. Chris.
Oh, I thought he was talking about you. I was like, I don't see no Chris in here.
That is a Chris.
Oh. Then I hate to be the one to tell you, baby, but unless I told it to you, I wouldn't, stake my flag to it, okay? Thanks. Moving on. What is the range of this function? What is the lowest most value? Negative infinity. Because you challenging me like it's the. I see. What's the highest value, y'all? All right. What are the zeros? -3 and 0. And finally, what is the y-intercept? Very good. Some people in my other classes, they kind of they were looking at it and they were like, it's not 1. I'm like, no. But you see that thing leaning? Look at it. It's not going perfectly through 1, but it's going perfectly through 0, 0. You feel me? It's close, but not quite. There will be no ambiguity on the test, okay? Okay. Ambiguity. All right, let's look at number 5. They're asking for the number of zeros, y-intercept, and the domain. How many zeros? Very good. Number of zeros. 3. Why is it all blurry now? That's cool. Y-intercept. What is my y-intercept? Just 9?
No, 0, 9.
Thank you, thank you. It's a coordinate, right? And then finally, what did I ask this for? The domain.
0.
Excuse me. Is this not a polynomial? Is this a polynomial? Is this a polynomial? Then what is the domain of every polynomial? Thank you. From negative infinity to positive infinity. Don't make this hard, y'all. Next. How many zeros? Thank you. Thank you, baby. What's the y-intercept? Thank you. And the domain. Yeah, we're not gonna make this hard, y'all. Because this is a polynomial as well. Okay? Pull out your notes. Okay. Oh, yes. We got some more notes. I need you to sit down and be still because time is of the essence. Sit down and be still. Quickly. Can I go now? Okay. Cool. All right. All right, guys. Turn to a new sheet in your notes. A new sheet in your notes. Go ahead and commit these objectives to your notebook. Today's date is March 15th, and we will only be fulfilling the first objective, where you're learning how to determine intervals of increase, decrease, and constancy of a given function. Only write that one down, okay? Just the first one. Baby. Focus. Yes. Have you written this down? Hurry up. As soon as you do, you can run. And y'all, those of you who like to chatter and carry on, please, I really don't have time for that. Time is of the essence, and I need to get through all of these elements before the end of the school day, okay? So keep your clever comments to yourself, please, and thank you. I got 4 slides I need to get to, okay? Say what? Just the first one. Just the first one. That's the only thing we're going to be able to get to today. Are we ready? Let's go, y'all. What does it mean to decrease? What does it mean to increase? Going up. And constant means what? Remaining the same, right? Look at this here diagram. Keep in mind, young people, when you're reading a graph, especially when you're developing your intervals of increase, decrease, and constancy, you need to read the graph. Always read your graph from left to right. Then read, this might be why you think I'm be teaching you stuff, because you be on your phone while I'm teaching you. Put your phone in your bag. Okay? Read your graph from left to right. Okay? Reading from left to right, this slope is pointed downward, right? Reading from left to right, this one is staying flat. Reading from left to right, this side is going up. Okay? Thus decreasing, increasing, and constant. Now, when you are naming the interval of increase, decrease, and constancy, okay, you must look to the x-axis, not the y-axis, okay? Let me show you what I mean. From negative infinity all the way over to 0, my function is decreasing, okay? From 0 to 2, my function is constant. Do you see? And from 2 to positive infinity, my function is increasing, okay? Simply put, this is how I would write it out. Keeping in mind, young people, let me just go back over that. Any portion of the graph in this region is decreasing. It's decreasing from negative infinity all the way up to 0, right? Trying to color it in, but it's getting messy. I'll keep it cute. Let's write out our interval, shall we? Increasing from negative infinity all the way to 0. Okay? Constant. What did I say? What should I have said? Well, y'all better be learning then, okay? Hey, I made a mistake, all right? See, what had happened was, I was just trying to see if y'all was paying attention and stuff.
Right.
Thank you, baby. Thank you, sugar. All right, very good, young people. Thank you for catching my mistake. The function is decreasing from negative infinity to 0. But right at 0, it switches gears, right? And it flattens out. So I am constant between the intervals of 0 and 2, right? And then right there at 2, Najee, it switches again. And it begins to increase, yes? And my function is increasing from 2, to positive infinity. Okay? Let's look at another one. Does that make sense? Yes.
How is it, we're going off the x-axis, right?
Mm-hmm.
How is it increasing? I mean, how is it decreasing?
Well, think about it like this. As my x values get bigger and bigger and bigger, remember, we're reading from left to right. As my x values get bigger and bigger and bigger, my function is going down. The function is the thing, the curve, the lines on the graph. Okay? The value of the function. Yeah, why? The values of the function, as x gets bigger and bigger and bigger, what is y doing? Getting smaller, right? So between what values of x is my function decreasing? Okay? Between what values of x is my function constant? Is it not changing at all? Between what values of x is it increasing? Good question. Does that make sense what I'm saying? All right. Let's look at another one. Look at this one. First, just look at the pictures and just look at what's happening, okay? Remember, we're reading the graph from left to right. What is it doing here from this point to this point? What is it doing? It's increasing, okay. What is it doing here? Decreasing. Remember, we're reading it from left to right, right? What is it doing here? Increasing, okay. Now, we just have to figure out the interval. Let me break out my highlighter. From all the way this way up until chink, 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 right there. My function is increasing, is it not? How would you name that interval? From negative infinity to where? To -1. Okay? And then it switches gears, right? And between -1 and who? What is my function doing? It's decreasing, huh? Okay. And then it switches gears again, right? So what would be my interval of increase again? 1 to positive infinity. You guys are catching on. I'd like to see it. Okay. Remember, even though the graph looks like it stops, it doesn't. All right, it keeps going on. Come on. Stop it. Keeps going on and on forever. Okay. May I proceed? All right. Look at this one. Real quick. What is my graph doing in this region? It's increasing. All right, let me get my highlighter. So from here to here, and remember, I start out here to just remind you guys that my graph, even though it stops here, it lives beyond this picture, okay? So from here to here, what is my graph doing? Increasing, okay. Oops. And from here to here, what is my graph doing? All right. And then, okay. So now all we have to do is name the intervals, shall we? Okay. Increasing from to 0. Boom. Does that make sense? Okay. Constant from where? Okay. And I'm sorry, decreasing from to the positive infinity. How we feel? Does this make sense? Okay. Real quick, I put a Snicker bar on it. To the person who can give me the intervals of increase and decrease the fast. I'll put 2 Snicker bars.
Hold on, 2 Snicker bars on what?
2 winners.
I got you right now. All right, what? Hold on.
Write it down. Nope,
Hold on,
nope,
wait,
you got it
wait,
written
wait.
down.
Say it again.
I need all intervals of increase and decrease. All intervals of increase and decrease. Write it down. That's one graph, even though that's called a jump. That's called jump continuity. But we'll talk about it later. It's on the same graph, so it's a part of the same function.
Oh.
Come on. You ain't gonna try to get it? Why? You don't do chocolate. Dang, I got some Jolly Ranchers.
Hey.
I knew you were gonna say something.
Shoot.
Yeah, bring it to me.
Skylar might do it. I don't know. This ain't my cup of tea. I deal with numbers.
All intervals of increase, decrease, and constancy. Is there any constancy here?
No, but
Okay. Mm-hmm. Yeah, that little snack piece over the side, that counts too. It's on the graph, ain't it?
Hey, watch this.
Watch this, folks. Watch this, folks. Watch this, folks. Watch this, folks. Look, Sharon, you don't answer.
Okay.
Okay.
You do the second line?
Okay.
Oh, look at your decrease. Oh, you're so, don't go nowhere. Look at what you did.
What you
Look at your decrease.
mean? Don't help. Don't help.
Look at your decrease.
Which one?
Your decrease. Your decrease.
Oh.
Come on, man.
She said there's two.
Let me see.
I probably still got it wrong anyway.
Oh, hush.
This ain't my
What you mean?
Hush, hush, hush,
I
hush,
wanna
hush.
show you- I don't do lines, I do numbers.
I just want to show you I'm gonna get the right answer. Regardless, man.
Baby, look at your X values for your interval. You did Y. Thank you. What is wrong with you? Don't get grand, because I shouldn't give you nothing, because you got it wrong the first time. You need to stay humble.
That one little mistake.
One little mistake. One little mistake. Yeah,
That don't be confusing me.
whatever. There's still one more candy bar on the line, y'all. One more candy bar. I know you know the answer. You don't want it. What's your motivation, man? What you want? What you want? School supplies or something? You hop up for a pack of paper or something?
I do need some fancy highlighters. But this girl had $30 highlighters. That was doing
Oh, for real?
stuff better than
You're really competitive, aren't you?
Not
Yeah.
enough of this though, because I don't deal with lines.
That's a good point.
All my teachers know that.
May I proceed? So, are we forfeiting the second bar? Huh? You can take them earbuds out your ear too. No, you can't get both of them. Come
All
on.
right, let me try. But I don't
Hey,
lines.
yeah, ain't nobody gonna try nothing in a minute. I'm about to go. Let me see. Let me see.
If it did wrong, I'm
Curse word, baby. Sugar baby. You looking at the y-axis instead of looking at the x-axis. The funny part about it is your decreasing is correct.
It's just my ink.
Your last decreasing is correct. What are you doing?
You said
All right, let's talk about it.
No. I swear to God, I'm getting close. I swear to God, man.
Sir, it is 3:17.
2 minutes, huh?
Hey, Google,
Hey, don't say that.
give me a timer for 2 minutes. Hush.
We're starting now.
Thank you, girl.
All right, I'm good, folks. Yeah, folks. Nah, still give me 2 minutes though. Still the clock's still running, right?
It's running.
All right. That's it right there, right?
Let me see.
I know I'm
I said, let me
decent.
see.
That don't count. That don't count.
What don't count?
That don't count.
You got a score? Okay.
Yeah, that right there.
What?
Yeah.
Okay.
I'm decent.
Hold on.
I'm decent, huh?
All right.
You know I'm decent.
Okay, what about the other decreasing?
What you mean?
What you mean? What you
Oh
mean?
God, give me that. Oh.
Hey, hey.
I got it right here.
Hey, man. He got it. He got it.
Skylar got it. Look at his glasses. Of course he got it. Boy.
Yeah, come here.
Far away, folks. You got a Jolly Rancher? Let me get that.
No.
Come on, I got that. Oh yeah.
Thank you.
All right. Let's talk about. We'll land it right under that. That was perfect.
Merch that I could have got there.
Why you mad?
Of course she do this when it's lines though. Like she could have been doing this. And she know I could have been getting Snickers every day.
You hopping out the window, but
Of course he's talking about some lines.
I can proceed. Okay. All right, guys. So he being nice. He's being nice to you.
I ain't earned it.
It's a Snicker bar. It's a Snicker bar.
Just go.
Yo, I don't think he's cool, guys. I don't think he's cool.
Maybe you need to give him another problem.
No, Nah, she doing this last. Like you salty in the mud. Alright.
Okay, guys. All right, we're gonna press forward. All right. All right. So in this region, pay attention, guys. In this region, that's cute, right? Okay. So from here to here, guys, my function is decreasing, yes? Okay? All right. Now, for those of you who did not enter the contest, or you may have had a late entry, okay? It's okay. Increasing from negative infinity. I'm sorry, decreasing. Did it again. Decreasing from negative infinity, say. It is, I'll fix it. From negative infinity all the way to 0. Tyler, do you understand what I'm saying now? Only focus on the x-axis. I mean, not Tyler, Skylar. I say I'm sorry. I say I'm sorry. Okay, decreasing. Now, it increases where? Okay, let me color it in for you. All right, from here to here, my graph is increasing. It's going up, right? So I would simply put 0 to 2. And then it decreases again, just a second. It decreases again from 2 to positive infinity. Let me color that in. Get a pretty color. Oh, that's too dark. Okay? Yes. You don't include the point. And you don't include it here either because of this issue here. Don't include the point. We're going to use parentheses the whole way. Okay? Now, something I want you to pay a close attention to. Let me get everybody's attention. You see that funky looking U there? We had 2 areas of decrease, right, Ashley? Pay attention. 2 areas of decrease. So what they did was they wrote the word decrease, right? And they united, okay? That symbol stands for union, okay? They united the 2 intervals underneath decreasing, okay? So this function is decreasing from negative infinity to 0 in union with 2 to positive infinity. Does that make sense, Anthony and Ashley? Okay, and individually increasing at between, 0 and 2. All right? And that's all I have today, folks.
Hold on. How is it in union if they not the same?
No, they're saying both. This function is decreasing in 2 places. Between this interval and this interval.
So it's the same function even though it broke off?
Yeah. It's called jump continuity.
So what would that look like?
With an equation, it would actually be, it would be something called a piecewise function. Okay? We haven't talked about piecewise functions, although you should have at this point. Y'all to talk about piecewise functions in Algebra 1? You have it. Okay. Well, what this would be, and I'm just pulling something out the side of my neck because I don't know exactly, but it looks like x squared, right? So the way that they would write it is like this. I'll write it here. Hey, y'all sit down. I'm trying to explain something to him and y'all throwing me off. It would look like this. I'm trying to remember. F of x equals, and it'd be like this, right? I think. I can't remember the symbolism. Skylar, thank you. So the first function, this loop-to-loop part, is x squared plus 1. Okay, shifted up 1 unit. But they only kept the graph that is less than 2. So x is less than 2. They kept all values less than 2. Look crazy, I know. Okay, and then that's a line. It looks like it goes through -3. Has a slope of down 1 over 1. Okay, so that's -x. But they only keep in the part that starts at 2 and goes beyond, right? So x is greater than or equal to 2. That's the name of that function. It's not one continuous equation. It's not like anything, you know, in particular. That's a piecewise function. It's in the name, pieces. Pieces of functions put together on one graph. Does that make sense? Okay. Made me reach in the back pocket. I ain't talked about piecewise functions in a while.
I ain't never talked about it.
But does that make sense though? Pieces of 2 functions on one graph. Thank you, sugar baby. Hey, put my types on my calculators, y'all. You didn't need them today. Really didn't. But it's to, if you needed to calculate something, it would have been available to you. Okay. Y'all feel like y'all learned something today? Ashley, you got something.
He said, follow me to the car. No,
Who's going to go on for y'all?
that's mine.
All right. Thank you kindly. Mr. Bright, these notes look better. I'm going to print them out again. Was anybody else absent yesterday? I gave them to. I got another copy of notes. 7? Great day in the morning. Oh, 3rd and 4th or just 4th? What about 4th? Just 4th? Who was it?
And Melissa.
Melissa and who else? Just 2 were absent? Right, Jetsamani.
And Amaya.
Okay, Amaya's still out. Okay.
We agree.
Got it.
And then you said, I think you gave them the notes today.
Yeah, I did. Come here, sugar baby.
Me?
Yeah, come here. Do me a favor. When it's printed out, give it to Mr. Bright for me, please. Thank you, sugar. It's taking long enough, though.
Hey, man.
Here you go. Thank you, sugar. Yeah, this is much better.